Hello friends, in this video we will learn about type of parsing which is shift-reduce parsing. Now what is that type of parsing? We have learned about your recursive descent parsing, right? And in this video I will show you the shift-reduce parsing. So this is another type of parsing method, that is parsing your sentences present in your text. So what is the type of that parsing? It is a type of bottom-up parsing. So what it means? It means that we are considering parsing tree and we are parsing that tree from bottom to up direction. So basically we are parsing that tree from leaf to the root part of that tree. And it will tries to find sequences of words and phrases which correspond to the right hand side of a grammar production and replace them with the left hand side until the whole sentence is reduced to an S. So basically in your context-free grammar which we have read, that the productions are given. So what we will do is we will see the words and phrases which are present in our sentences and we will match those words with the right hand side of the production. And if there is any matching of right hand side of the production, then we will replace them with the left hand side of that production and we will iterate this process again and again until the whole sentence is reduced to an S, which is your start symbol, which is present in your first production. Okay, so I will show you an example. We will implement this process using stack. Now you know very well what is stack. Stack is based on LIFO, that is last in first out. Okay, so we will use that stack for implementing this process. So basically its name is shift reduce parser. So we have two operations, that is shift and reduce. So first is your shift operation. So this parser will repeatedly push the next input word on the stack. So we will tokenize our sentence and we will get different tokens, different words. So we will push those words on the stack. And then this process is known as your shift operation, since we are pushing something in the stack. Next is your reduce operation. In this operation, what we will do is, if the top n items means n words on the stack, match the n items on the right hand side of your any production, then they will be popped from the stack and the item on the left hand side of that production will be pushed in the stack. It means if there is any matching of the word present in your stack to the right hand side of any production, then we will replace them with the left hand side. That is, we are popping them and pushing your left hand side part of that production. So this is known as your reduce operation. Next is, the operation may be applied only to the top of the stack. Reducing items lower in the stack must be done before later items are pushed on the stack. So before pushing another words on the stack, we will reduce those items first. So this is your simple shift reduce operation using stack. Now the parser will finish when all the input is consumed and there is only one item present in the stack, which is your S, that is your start symbol. Okay, and it will build a parse tree during the above process. So basically this parser will build a parse tree and each time it will pop an item of the stack, it combine them onto a partial parse tree and push this back onto the stack. Okay, so this was your simple stack implementation. Now we will see a program of that in which we are using your simple NLTK module and it will provide shift reduce parser direct inbuilt function and we will use it. This parser does not implement any backtracking, so it is not guaranteed to find a parse for a text even if one exists. So basically this is your disadvantage of this parser, that it does not implement any backtracking. So if there is any match, then sometime it will not parse that text. We will see the example of that. Furthermore, it will only find at most one parse even if more parses exist. If there are multiple parses, then but still it will give you one parse. So these are the two disadvantages of this process, but still it's very advantageous for us. Okay, so I will show you one program and one method also. I will show you an example and you will be able to understand that what is that parsing. Okay, so let's see it. Okay, now I will show you shift reduce parsing example. So as we have seen in our recent recursive descent parsing, again we have to type the command nltk.app.sr parser at the place of rd parser because it's a shift reduce parser. And see, this window will open. And these are your CFG, context-free grammar, and this is your example again. My dog saw a man in the park with a statue. Now, how we will parse that sentence using your shift reduce parsing? Let's see it. Okay, so first step will be your simple my. My word will be checked here in the productions. My is your simple determiner. Okay, then it will become this production. Determiner is your simple my. Next step is your dog. Each sentence will be taken, okay, and then it will be either shift or will be reduce operation will be performed on that word. Next step is your dog. Dog is again meshed with the noun phrase. So this will become your noun phrase. Next Since it's a bottom-up parsing, so we have creating a tree from bottom to up, not top to down, which was in the recursive descent case. Okay, so this will become your noun phrase, determiner, and noun phrase. Okay, so this is your noun phrase, my dog. Next step is saw. Saw is your simple verb. Next is your determiner, and now man is your noun. So determiner and noun will become noun phrase. So this will be used here. Again, noun phrase, verb and noun phrase will form verb phrase. This production is matched there, so it will be taken. Okay, and again noun phrase and verb phrase is your simple S, so this will become S. Okay, now again in is your determiner, preposition, sorry, the is your determiner, and park is your noun. Okay, so determiner and noun will form simple noun phrase, and noun phrase and preposition will form prepositional phrase. See the production and you'll be able to understand it. And finally, we are getting with, which is a preposition, is a determiner, and statue is a noun phrase. Again, it will form a simple prepositional phrase. Okay, now any like prepositional phrase, we have two prepositional phrase here? No. So in this way, your tree will become like this. So this is not your final tree, because it's not able to form the complete tree. We know that backtracking is not possible here, so that's the problem here. So since, see, this is the failure is showing here, because this example is not because shift reduce parsing is not able to parse this example, and the reasons can be like it's do not use backtracking. Okay, again there are other reasons also. So we have seen two disadvantages, so those can also be the possibility here. So process will be like this, but it will give you a tree or not, it depend on the example. So this was your shift reduce parsing, and I have also shown you the example of recursive descent parsing. So in both parsing, both are advantages, but recursive descent parsing is mostly used. Okay. Similarly, if you write the code, program code for this parsing, then you can use the same code which we have used for recursive descent parsing. But the difference is that we have to use their shift reduce parser function instead of recursive descent parser. Only the change you have to do there is that you have to just change the name of recursive descent parser to shift reduce parser, in which shift S will be capital, reduce R will be capital, and parser P will be capital again. Okay, so I will write this function. This is your function in which S, R and P will be capital. At the place of recursive descent parser, you have to write this command. So this is the way you have to do. Okay, and that was your shift reduce parsing. So